So the power button over on the side over here is not operational and the computer won't go on. So I'm going to use a Phillips screwdriver and a couple of little plastic tools I've got for opening up the case, and we're going to go ahead and flip it over. And there's screws here, 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 and two back here that we're going to take out. So let me just take these out. I got a nice little magnet right here that I'm using to keep track of my screws. So the tricky part is we have to pry right along this edge carefully. There's a little catch inside there. So let's try the wider tool first. And let's see if I can get up underneath here and pry this out a little bit. I think I'm going to use a small screwdriver as well. I'm going to get this in here carefully, apply a little pressure upwards like this. And you can see it slowly popping up. Okay, so there, now it's coming up, and you can see these little tabs right in here. That's what held that down. Now I've actually made the repair on this one already, but I still want to show it to you. And I want to show you what I've done. So it's easy to pull this out of the way. Here is the original part right here that I took out. And there's supposed to be 3 micro switches on here. This is the power button. It's missing that micro switch right there. So, right in there. This is the new part. It's held in with 1 screw. That I'll put on my magnet so I don't lose it. And I'm going to carefully take this off. And the connector, which is right over here, this one just carefully unplugs. And you need to make a note of which way this plug goes because it only goes one way. The side where you can see these connectors, that side goes down. I'm going to leave that plugged in right now.
I can now see how the plastic button mechanism works. The button is designed to incorporate a spring mechanism. Under this hole is a raised rib cross that it slides on. Somewhere around this hole, a piece of plastic broke off that provides a pivot location. I can also see how the button is pushed in. The geometry of the spring mechanism needs to be restored. I will fabricate from an old AAA card a small shim that happens to be the right thickness. That thickness is 1/32 of an inch. That will be placed between the spring hole and the mounting screw rib support.
So there's something right in here that holds this in position for it to pivot off of it, and that breaks, or there's broken piece inside there, and that causes this button to push way in too far. This button has to be able to just do this a tiny bit. And so what I did is I got a little piece of credit card and I cut a small shim here, and this is 1/32 of an inch. I have a 1/16 of an inch plastic, but it wouldn't fit in there. And so I'll show you how I designed that. And originally when I put this together, that was sticking up higher. And in order to reinforce that, I designed this small piece of 1/16 inch acrylic plastic, and I'll give you the dimensions and show you what that looks like before I glued it in place. So I glued this in place to give this some extra security. I didn't glue over here, I only glued on the back side because it still has to pivot on that. And in order to make sure that this switch here does not break again, I put a tiny little piece of plastic right here that will sit right here, so when we push on this button, it doesn't push it off and break it that way. And so I had to take and grind this off to make it flat when I got finished. This Dremel tool, along with this bit right here and this saw blade bit, played an integral part in being able to design this repair.
Here's a quick example of how I made the shim to correct the button spring geometry. And now the fabrication of the shim support. I have placed blue painter's tape on the plastic. I'm using a machinist rule that has millimeters on one side and inches on the other side. I will measure and draw lines where I want to cut. I will use my rotary tool and the circular saw attachment to cut the plastic. There is an image at the end of the fabrication process with the approximate dimensions. These values are approximate and may need to be adjusted to fit. Check the fit of the shim and the support and modify it as needed. Then, very carefully apply a small amount of high-strength plastic glue. It's been less than 2 minutes and the glue has set enough for me to pick up the box. It will fully set in 24 hours. I like this glue because of its strong bond, precise applicator, and how it flows between the joints.
And when you place this back in place, because this button has been tweaked a little bit, and it doesn't quite fit properly all the way back in, this edge right here was just a little bit too high. So this is what pushes on the button, and because this doesn't fit 100% all the way back, I had to take this Dremel tool and this little bit right here and just carefully shave a smidgen, a tiny bit off of that surface right there. And what I had to do is I would put the switch back in here, And then I would put the screw back in because it needs to be exactly how it sits. Don't try to do this without the screw being back in place. Okay. Then when you push the button, you listen for the click. Now let me bring the microphone close. If you're not hearing the click, which is what was happening, that meant the button was being pushed all the time. So I would remove this, use a little Dremel tool, just shave just a tiny bit off of that end there, put it back in, and test it again. And so I did that consistently until I got it very consistent, and every time I just barely touched it, I could feel and hear the clicking noise of that switch. Now that I've got this all adjusted, everything can be put back together the way it was. Before I put the screws in, I turn it over and I turn the computer on and I test it multiple times. Once I'm happy that it's working, then I can go ahead and put everything back together and put the screws in. So we're just going to put this piece back in where it goes. And let me tell you, it wasn't till I had this set properly that I would go in and I made that small piece of plastic underneath there. I determined where it would sit to give that switch support, and then I carefully glued it in place. Checking my wires, checking my screw, checking my plug. And this will just snap in place nicely. And since I know that this already works, I can just go ahead and put my screws back in place. I like to start with the center screws and work outward. Being careful not to over tighten them. Once again, there's that Dremel tool. There's the saw blade tooth that I used, and the narrow little abrasive tool that I used.
The replacement part is on the right, and both parts look and function identical, except the new part has a longer wire. And there's something else. The part numbers are not identical, even though the part number on the box is the CN-03G1X1 part number. The part number in the box was a CN-085GTT. And who cares if the part numbers are different if it fits and works? Not me. Except it didn't fit. The dimension shown on the new part is 0.3 of a millimeter longer. Now, that's not very much, but believe me, because of this distance being too long, this part would not fit. Lucky for my rotary tool and the abrasive narrow bit, because I was able to carefully and very carefully grind down the half circle hole just enough to make the part fit.
So I always have some pieces of acrylic plastic. These are 1/16 of an inch, which I needed. If you go to Tap Plastics, you can often buy just scrap plastic for almost nothing. So you only need a very small piece for this job. Just a little corner edge is all I needed from this piece of plastic. If you can get a 1/32 piece, then you should get that plus a 1/16 of an inch. You do need the 1/16 of an inch. I didn't have 1/32 of an inch, so I ended up using an old credit card for a small piece that 1/16 of an inch was just too thick, and I needed a 1/32 of an inch. So you'll need some of this along with some tools to fabricate this.